Hi, this is the second lesson in our series about communication in our course on communication, research, and analysis for scientists and engineers. In this lesson, we are going to talk about a straightforward way of structuring a discussion about a scientific, engineering, or other technical project. This will ensure that your audience will be able to follow what's going on. Students think they get high grades for coming up with great ideas and then implementing them with technical competence. Unfortunately, this is not enough to guarantee success. A demo is great, but to really show the value of your work, you'll have to give presentations and write reports, dissertations, and theses. That continues in the real world, where you'll have to write proposals to get your bosses or funders to back your ideas. Getting them to pay attention isn't always easy. The reason most technical people fail to get their ideas noticed is that they dive straight into the details. This leads to confusion because the audience doesn't have time to understand what the project is trying to achieve and why it's important. However, there are things you can do to help your chances. Today, we're going to talk about the elements that go into making a technical argument. One that is structured so that you can take your audience from their initial state of blissful ignorance to where you want them, well-informed and on your side. Remember though, this is only an introduction. When you're done with this video, you should go and read Chapter 6 of Explaining the Future so that you can get the full detail and examples. You don't have to read the whole thing for this lesson, but I'll give you more details about that at the end. Let's start with an example. What if I wanted to describe to you how the world's smallest and lightest ion and neutral mass spectrometer was designed? Would you immediately get excited about it? What if I were talking to a broad audience with people from lots of different technical backgrounds? Would they understand why this work was important? As technical people, we often forget that facts that are perfectly obvious to us are not obvious to others. Some of your audience might know what an ion and neutral mass spectrometer is and why scientists might want to use one, but most will not. Even if they know what the instrument is, they may not understand why creating one that is especially small and light is in any way interesting. Context starts with a vision, how whatever it is that you're discussing will make the world better. For instance, in my example, I could start by talking about the mysterious rings of Saturn and the astronomers who, over the past few centuries, have gazed up at the planet and wondered what the rings are made of. After that, it would make sense to get into the goals of the Cassini mission, launched to solve this mystery by collecting samples of Saturn's rings. Of course, sending these back to a lab on Earth is impossible. They would have to be analyzed right there on the spacecraft. That's what an ion and neutral mass spectrometer does. It separates out and measures the various ions and elements. Next, I would want the audience to think about the constraints on the ion and neutral mass spectrometer. Remembering that Cassini was designed and built in the 1990s when lab instruments would have been as big as filing cabinets, I would point out that this one had to fit in a small space, weigh less than 10 kilograms, and consume less than 30 watts of power, which was the equivalent of a small, dim light bulb of the time. At this point, the audience is finally in a position to appreciate the system and the device miniaturization done to create the new instrument. They can grasp the importance of the work and the difficulty of the technical task, and get down to trying to understand the what, why, and how of the work that was done and the results that were achieved. These are the bits of the story that scientists tend to be good at telling. So, if you want to explain your project well and clearly, you need to start by focusing on the context. There are 4 steps to doing that well. First, you have to make clear what your vision is for the project. What's the big goal that your project will contribute towards achieving? Essentially, you have to make sure that your audience are interested in the destination you're heading towards, or they will never make the journey with you. The vision could be saving lives by curing a dangerous disease, more immersive video games, or just making money. But if you don't explain it, the rest of the talk makes no sense. After we explain what we'd like the future to be, Then we have to make sure that everyone understands the limitations of the present. New technology is pointless unless there's a reason why today's technology isn't good enough. The status quo is the way things are now. You have to explain this in terms of what's wrong with today's technology. This might be performance, functionality, cost, any feature where improvement will help enable the vision to be achieved successfully. Remember though, the point of this exercise is to set up the work you're going to be describing later. The only criteria you absolutely need to go into are the ones that are relevant to the work that's coming up. What's critical about the status quo is that you use it to provide a benchmark or starting point so that once you make progress, people can see how far you've come. So, make sure to explain how slow, expensive, or inaccurate the current technology is so that you can show how much faster, cheaper, and more precise the new solution is later. You are essentially creating your own rubric for success here, and you will go back through these issues at the end of your discussion to show how the new solution fared. Before you get to that, though, you need to explain what was holding progress back. What is it? An algorithm that scales badly? Poor material purity? Low process efficiency? Whatever it is, we need to understand the narrow technical problem that's being solved and how it will help us achieve the overall vision. Whether you're writing about your own work or that of others, the solution that's the focus of your argument is likely not the first attempt at tackling the technical problem you've described. So talk about the other solutions out there. What are they good for? What constraints do they work under? For instance, there are all sorts of vehicles that work as transportation, but they're not interchangeable. What do they do well and badly? When can you use one but not the other? Most importantly, why do you think they can be improved upon? Finally, you're ready for the main event, the new solution. What is it? How does it work? How will it work if it's a design? How does it avoid the pitfalls of the others you've considered? If there are results from simulations, prototypes, or better, present them. Again, this is the section that most scientists and engineers find easiest to deal with structurally. The main way that they get in trouble here is the jargon, so be careful with that. It's important to discuss any obvious obstacles to the success of the new solution. If you don't bring them up, others will, either asking questions in presentations or reviews, or just wondering about it themselves. This could leave you looking foolish, deceptive, or both. On the other hand, if you raise these difficulties yourself, you can suggest ways to mitigate or get around them. Finally, you should compare the new solution with the competing solutions you discussed earlier so that the audience can understand whether it indeed represents progress. Also, close the loop by showing how it contributes to the overall vision and give some kind of prognosis for the future. What needs to be done next? What will this mean for users, science, the environment, or whatever the domain is where you want to see improvement? Okay, that's it for our introduction to the technical argument. To really understand how this works, you now need to go and read Chapter 6 of Explaining the Future. You don't need to read the whole thing for this lesson. Stop when you get to the structure section. We'll cover the rest later.